So good morning and welcome everyone. While we're waiting for people to join with audio, I suppose we'll get kick started. So thank you all very much for joining us today. And we're looking forward to a very interesting session, which is around Enable 6G. And we're looking particularly at the tech adoption scenarios for the future 6G networks. So my name is Brendan Rowan. I'm a managing consultant at BlueSpecs, and we are partners of the Enable 6G initiative, which is led by IMDEA Networks, and also with the partners of Telefónica and NEC Europe. So Enable 6G, which is part of the España Digital strategy and also the next generation new initiatives, is really about driving forward the development of the next generation of networks that are more intelligent, more configurable, more functional, and also more marketable as well. So we look forward to bringing to you the discussion today, which is going to look at really what is the next evolution of what is currently 5G. How can we make it better? And how do we lay the ground for what is 6G, which is what Enable 6G is all about. So today on the agenda, we'll be talking through different types of technologies that are coming out of the projects, but also different contexts. So we'll be looking at privacy-assured algorithms, autonomous networks, sensing throughout the network, application of reconfigurable intelligent surfaces, and even looking at Li-Fi, so powering small devices through light. We have today a jam-packed agenda, so if you just go to that slide, that will sure to be of interest. So we'll be starting with just a quick overview from our colleague Jose Luis. So Jose Luis will be giving a quick introduction over what is the market currently for 5G and why are we talking about 6G now, and talking about some of the use cases that are driving demand for these type of networks. We'll then be hearing from Tim from IMDEA Networks, who'll be giving us an overview of what's happening within the MAP-6G project as part of Enable 6G, and giving us a brief understanding of where it is that we're going in terms of application of AI and machine learning systems within networks. And then we'll be looking from Nicolas, who'll be joining us from Telefónica I+D, who'll be able to talk through what is the future applications of these type of privacy secure algorithms and federated systems that we'll be applying for future network management. Before then handing over to Jörg, who will be giving us a review really of what is it that's happening within RISC-6G. So one of the areas that's looking at the more foundational areas of technology, and the applications will be coming from Jessica, who is joining from NEC Labs. So the first part of the morning, we'll be giving you an understanding of what is the context, what is the different technology areas that we're talking about, and giving you that one eye on the future of where we're going towards 6G. And then the second half of the day, of the session, which is on the next slide, we'll be looking more about the discussion around how is it that we, first of all, address industry demands when applying these intelligent networks. How is it that we can ensure that 6G is improving constantly on its market readiness and the capacity to be part of different systems? We'll be looking at the role of standards, really important for that go-to-market approach within technologies, and that will be led by my colleague Tanya, looking at what is the different areas of 6G standardization development. Where are we now? What's going to happen over the next few years? And then finally, we'll be handing over to Maria, who will be coordinating the panel that will be looking on how we can really drive forward the trust in the application of AI in these novel networks to give us what we need from the networks of the future in that way. So without going into further much detail, I'll be handing over to my colleague Jose Luis, who'll be giving you a brief overview of what are we talking about 6G now, when 5G is still in deployment. And also any questions that you have, please use the chat and we'll be monitoring that as well. And just a reminder that this session is recorded as well. So thank you all very much and looking forward to a good session.
Thank you, Brendan. Hello, everyone. My name is Jose Luis Lorenzana. I'm a senior consultant here at BlueSpecs, and I'll be talking about the pioneering use cases and market insights for 2030 for 5 and 6G. So to begin with, I'm just going to share a little bit a basic overview of the timeline in terms of mobile networks. As probably most of you here know, 5G is the fifth generation of wireless telecommunication, and it is not an upgrade from 4G, but rather is a new comprehensive network architecture that provides a platform for new services, applications, and business models. So the first 4 generations of wireless communications were really about upgrading the previous infrastructure, and 5G presents this opportunity for new business models. And this is continued on the 6G, which will build on the strength of 5G and 5G Advanced, and brings in higher capacity, lower energy consumption, and many other benefits that we will see later on. And the key differentiator then will be the deployment of the start of the cloud edge continuum. So in terms of 5G, you go to the next slide, please. We can see in the global coverage that we have a clear differentiation between regions. There is mostly widespread coverage in China as well as in the United States, and sort of mid-level in Europe and Australia, New Zealand region, with lower coverage in Africa, South America, and also the Middle East. In this sense, in this case, we are talking about the 5G basic. Let's say it doesn't cover also the mid-band, which would be beneficial also for some of the use cases that will be required for some of the use cases that we will talk through in this presentation. So in terms of the positives of the 5G regarding the contribution to GDP, we can see that it is estimated that 5G will contribute around 1 trillion euros by year 2030, with the majority of these benefits surrounding the area of healthcare, but also with around 40% of the estimated impact, but also on different fields like smart utilities, consumer media applications, industrial manufacturing with 10%, and financial services applications with the smallest participation in this impact. However, if we go to the next slide, please. There is also some challenges. So in this graph, I've tried to show the benefits that 6G will bring over 5G and why we are already talking about 6G and how is it needed. So for example, in terms of capacity, there are already 1.6 billion contracts in 2024 for 5G telecommunications. And it is expected that the user experience data rate of these contracts will triple from the values from 2022 to 2030. Additionally, a benefit that 6G can provide is added accuracy, so up to 30 times more accurate in terms of location, and perhaps even more importantly, higher energy efficiency. So with improvements of over 300 times the efficiency of 5G. Then this leads us to the main 6G goal. So what is really the target for 6G over 5G? With connected intelligence, programmable, deterministic, integrated sensing, sustainable, as we mentioned about the energy efficiency improvement. It has to be trustworthy. Also on the privacy, we will see a few use cases and presentations from our colleagues on privacy, and also, of course, there's the solution to the affordability and scalability issues of 5G. So, which I will talk about here now. There's of course a downside of 5G. I believe I've had a quick look at the presentations that we will see today, and this is mentioned. The European Commission calculates the cost of the network expansion at 33.5 billion euros, of which 30.8 is expected to come from the industry, and only about 2.7 would come then from subsidies and government investment. So this is in an area where, in a moment where telcos are struggling to recoup the investment in infrastructure. There's been really big investments in up to 4G, 5G from telcos, and the return on investment for that infrastructure is not really seen by the telcos. So this means that complementary business models are required in order to ensure the correct coverage of 5G and also to ensure the viability of the networks in the future. So in this sense, looking for new use cases and new business models, I've here mapped some projects and use cases that are doing exactly this, and having focused in 4 key areas of improvement that 6G will bring. I've tried to map some of the projects that are related to enable 6G and also previously unlock. So, for example, in terms of the latency, we can see projects from Nebulous regarding the use case crisis management, and also the AEROS project with the use case of Smart Edge for Continuum. Our colleagues from India will talk today also about some use cases, but we can see in terms of the energy demand, they worked on the system architecture for battery-free IoT networks. So regarding Li-Fi and other low energy applications. And then for capacity, we have the Fluidos and the NEMO project with the use cases robotic logistics and smart media city and XR. And then finally for the privacy use case, increased privacy use cases in the project Nefele, the remote healthcare applications and use cases. As we saw, healthcare is expected to take a big part of the have a big part of the impact, economic impact in 2030. So this is a very interesting use case in that sense. Then also our colleagues from Telefonica will be presenting the privacy preserving AI use cases, which for sure will have a very big impact in the future. And then in the ICOS project, there's also the use case of in-car advanced infotainment and multimedia management system. So with that, we have a whole presentation with many interesting projects. I hope I could contribute a little bit to paint the bigger picture of where 6G fits and where we will be in 2030. And yeah, thank you very much for listening. Back to you, Brendan.
Thank you very much, Jose Luis. And I think putting into context there that we need to start talking about 6G now because the applications that are going to require these networks are getting more and more complex. And I think that's one of the key interesting parts of what Enable 6G is doing and what we're trying to discuss here today is, how are we going to increase that capacity? How are we going to ensure that we have the infrastructure in place? And how are we going to make sure that it makes business sense for everyone involved? I think that's one of the key things that we'll be talking throughout the day, and also looking forward to how really the building the business case for the network also relies on the maturity of what's happening in terms of the edge continuum, but also all the different areas there, and really unlocking that value that we can achieve with all the technologies that are converging at the moment across this area as well. So I think we're a little bit ahead of time, but I think we can go ahead and buy ourselves a little bit more flexibility. So coming up next, then we're going to hear from Timothy Otum, who's a researcher in Dare Networks. He's going to present the areas of work within the MAP-6G. So some of the pieces that we've picked up there, which is the greater energy efficiency, greater capacity, greater autonomy, and generally much better networks achieved through the application of secure and private federated learning and machine learning systems. So Timothy, over to you to give us a quick overview from what's happening in MAP-6G.
Thank you, Brendan. Is it possible to share my screen? Okay, now it's possible.
And a reminder to all of you who are joining us, anytime you want to put a question, just please put it in the chat and we'll pick it up from there.
Well, is it now possible to see my screen?
You just need to swap your displays on display settings at the top there. we're seeing your presentation mode.
Hold on. How about now?
It's at the very top if you go to display settings and if you just change swap displays. Yeah, exactly.
Should I choose duplicate?
Swap presenter view and slideshow.
Okay.
Great, thank you. Go ahead.
Okay, hi everyone. My name is Timothy Utim. I'm a postdoc researcher here at MDR Networks, and I'll be presenting the objectives and status of MAP-6G. MAP-6G stands for Machine Learning-Based Privacy-Preserving Analytics for 6G mobile networks. Also in this presentation, we shall have Nicholas and Yanis from Telefonica giving us an update of the progress of their activities. So let's begin with this overall objective of MAP-6G, which is to integrate communication with big data analytics for applications such as localization with privacy-preserving solutions by design. So in this overall objective, we have some keywords. For instance, communication. In 6G networks, the aim is to go beyond the current use cases for 5G in terms of communication, for providing extremely high data rates and ultra-low latencies for communication. The other keyword that we have here is big data analytics. So with 6G, there is going to be an explosion of data, and it would be really interesting for us as researchers to leverage these huge amounts of data in form of machine learning or AI models. The other keyword in this overall objective is localization. Now, when it comes to 6G, location data will play a very huge role, like never before, in providing complex services in 6G, and that is why we have it as a keyword here. And the other keyword is privacy-preserving solutions. So with 6G, there are going to be opportunities to provide more and complex services, and also there will be a likelihood of an increment or an increase in the privacy threats. So that is why it is important for us as researchers to build systems that are privacy preserving at the same time. So this is the overall objective of MAP-6G. So this brings me to the specific objectives of this project. The first specific objective is to design high accurate joint location and localization capabilities, mainly for providing better network services than in 5G in terms of high accurate localization capabilities and very high data rates and extremely low latencies. The other objective is to design privacy-preserving solutions based on machine learning or AI techniques. The third objective is to test all these technologies, to test them in different 6G scenarios. And the fourth objective is to exploit the project results in form of publications, and then also in form of webinars like what we have here. So here is a summary of the work plan. MAP-6G is composed of 6 different work packages. And here is a figure that shows how all these different work packages are interlinked to each other. Also, it shows the different partners who are playing a role in each of the different work packages. For instance, MDR is leading the work package on project management and the work package on building localization algorithms, and also in defining the use cases, requirements, and system architecture. When it comes to the work packages on building machine learning-based movement and network analysis, Telefonica, and a company called P-Lighting are the ones leading this work package. And MDI and Telefonica are also working on the work package on machine learning-based privacy-preserving analytics. When it comes to communication and exploitation of the results, well, BlueSpecs, Telefonica, and MDI are all working together in this work package. And here is a figure that shows the different activities and the duration of these activities in the project. On this axis, the y-axis, are the different activities, and on the x-axis are the duration of these activities. The key takeaway from this figure is that the project has been going on for at least 12 months, and at least for 12 months for most of the partners. And we are also left with about 12 months to the end of the project. So here I will present the current progress of MAP-6G from the side of MDR. This is one of the works that we have been performing here, and it's related to localization. So the main motivation behind this work was that when you look at the standard, for instance, of 5G, and the works in the literature or in the state of the art, you find that most of the works have been based on simulations. So this is the gap that we wanted to exploit by building a real test bed that can be used for experiments. So the first figure shows our test bed being deployed in an outdoor scenario in Rome. In Rome because we were working with one of the collaborators there. So this figure shows 3 base stations and the user equipment. And we performed the measurements here, and we analyzed the results. The method that we used here was the time difference of arrival, and the signals that we used for localization were the positioning reference signals. So the second figure shows how we performed the signal processing so as to estimate the location of the user. And the figure here, the third figure, shows the results. And the results are really interesting in the sense that we're able to localize the position of the user at an accuracy of about 3 meters. 3 meters at least 90% of the time. So we have also been working on wireless technology classification. So this work was presented in Infocom of 2023, in the sense that we believe that in 6G systems, 6G systems, spectrum management will be key, in the sense that it will have to be real time, and it will have to be highly accurate. So here we built a framework. We built a framework for wireless technology classification, and the first figure on the bottom shows the different technologies that we were classifying. For instance, we are classifying FM signals, GSM, 4G, Tetra. And the second figure at the bottom shows the overall architecture. So we had sensors deployed in different parts in Europe, collecting spectrum data. And this data was sent to the back end. And at the back end, we're able to detect the live signals, and which we classified using an LSTM model. And here, the third figure at the bottom shows the results. And if you take the average of the accuracy here, you'll find that our framework is able to perform, or was able to perform, classification at an accuracy of about 94%. And when it comes to deploying this framework, we did find out that when it comes to the latency for executing this entire framework was about 2.5 seconds, which is near real time. So this is a good start in order to build a framework that can be able to play a role in 6G networks. So here I present another framework that was developed by our colleague Claudio, called Explorer. Explorer performs, it's an explainable AI that is used for interpreting actions of a deep reinforcement learning agent. So the first figure here shows Explorer interacting with a DRL agent. So we have a DRL agent here that is able to perform some actions so as to meet a given set of KPIs in the environment. So when the DRL agent performs some actions, these actions are picked up by our framework called Explorer. This framework is composed of two stages. In the first stage, you have this XAI, which interprets these actions. And in the second stage, which can be shown here, this second stage modifies the actions which were made by the DRL agent. So we were able to deploy this agent, framework in Open Run. And here is the whole architecture with Explorer in Open Run. We have the DRL agent here making some actions so as to meet some KPIs. And these actions are picked up by Explorer. Remember, Explorer is composed of two agents. Of two steps. The first step, which explains the actions of the DRL agent, and the second stage, which modifies or refines these actions so as to improve the overall performance of the network. So after refining or modifying the actions, the actions are then sent to the environment. And in this case, the environment is the base station. So in this third figure, we show you the performance of our solution in terms of KPIs. Here on the y-axis, we have the downlink buffer, and on the x-axis, we have the transmitter bitrate. And the legend here shows the different policies as a result of the actions of the DRL agent. For instance, when the action leads to the same physical resource block here, you find that there's a low variation in the downlink buffer, and at the same time, the transmitter bitrate is more or less constant. And for instance, when you look at when the action leads to a distinct policy, which is the star here with the green, you find that there's a very large variation in the downlink buffer, and also there's a slight change. There's a change in the transmitter bitrate. So our framework was able to perform was able to explain the actions of a deep reinforcement learning agent. And this work was presented in the CONNEX of 2022. So here I present, I will not talk much about these two works. These works have been accepted for Infocom 2024. And in these two works, the first work is that we performed localization of a non-cooperative transmitter using spectrum data and 5G Open RAN. And in the second work, we performed a real-time attack detection in 5G Open RAN. So these two works have been accepted as part of Infocom 2024. So with this, I would like to invite Nicholas to give us a brief presentation of the.
Thank you, Tim. Thank you, everyone, for being on the call on the webinar. So from Telefonica side, we are working on various things. One of the problems that we're trying to solve is around the area of how to design machine learning algorithms that are scalable, that can be executed in a distributed fashion, and at the same time preserve the privacy of the data that are being used to train the models. Maybe we can proceed a bit. A couple of building blocks, as I call them, that we are considering at the point is federated learning and differential privacy. There are obviously several other ways to train machine learning models in a distributed fashion that preserve the privacy. For example, multi-party computation that is not so scalable. You can use tested execution environments, but you need specialized hardware for that. So we decided to look into the FL and couple it with differential privacy. That being said, we started looking to how to train models inside mobile applications in a cross-mobile application scenario using the paradigm of federated learning. And this will also allow us to perform the cross-silo concept on mobile phones. Next click, please. Here I have a visual of what we started building in the last years that reflects this concept. So you have the different mobile applications. Each one has some portion of data that are interesting for the specific model. And they can be trained, they can be used to co-train a model locally in each device. This is the cross mobile scenario. And then across devices, you can build the cross-silo type of model. Maybe we click a few more. Now, beyond that, we started looking into the concept of hierarchy in the networks and how these can be incorporated, how it can be used in the federated learning setting, along with differential privacy. For that, you can see the other diagram. We started looking into various types of attacks that can manifest in this HFL, this hierarchical FL setting. We assume that we can have intermediary nodes in this originally client-server scenario. So now these super nodes, as we call them, that are in between, can help with aggregation of the models, with injecting differentially private noise, and overall improving the utility that you get for the privacy that you are requiring. Maybe one last click, experimental evaluation, which we already started performing for both of these sets of works. One for this FL as a service type of platform, and the other one for the HFL, using different models, different data sets from the state of the art, and assuming performance metrics that are in literature. Then we have several ongoing submissions, so I cannot say more about that. Yannis?
Yes, hi everyone. So I will move on to a somewhat different domain, which has to do with control tasks. And in particular, we are looking into how we can optimize mobility in a cellular network, which is a vital and high impact service. And more specifically, we are examining and researching ways to optimize the handover scheme. The handover scheme, as you probably know, or for those who don't know, who are not familiar, it's implemented at the edge. So we're talking about edge AI technologies. And there is a high demand for real-time and scalable decision-making. Decision-making that's responsible for routing mobile devices, user devices from one cell to the other as users navigate in an urban area. And this can have a tremendous impact on the quality of experience. For example, we may have disruptions in data services when the handovers are delayed, or data throughput can suffer when a handover makes a suboptimal choice, such as, for example, shifting a device to a slower 2G cell instead of a high-speed 4G or 5G cell. So in essence, making a well-informed handover decision requires considering a wide array of key performance indicators, those which include the quality of experience, the energy consumption, the performance impacts, and so on. Therefore, this gives rise to a very complex and high-dimensional and multi-objective optimization problem, which we are trying to address using reinforcement learning technologies. So in the work that we've been doing in the past months, one of the primary goals was to address these challenges by developing a distributed multi-agent reinforcement learning solution that can function within cellular network environments that are characterized by heterogeneity and multiple optimization objectives. And this demands warrants research on several fronts, including developing algorithmic cooperation mechanisms that allow the agents to collaboratively optimize multiple objectives. Therefore, we are talking about altruistic agents, but also the implementation of neural network architectures that can accurately approximate optimal agent policies for this specific problem. And in particular, we've been aiming to develop a method for efficient and distributed network optimization of cellular networks. And to this end, we've been leveraging advanced multi-objective, multi-agent deep reinforcement learning systems for efficient, distributed, and real-time handover optimization on the network that is at the edge. We also plan to focus on optimizing active state handovers, where basically the base stations actively participate in the decision-making process. And in this scenario, we envision deploying cell-based agents that assume control of the handover decisions within the cells that they are deployed to. Contrary to other applications of RL, we also envision agents to be deployed directly on base stations. And these agents also exchange with neighboring agents to enhance collaboration and make optimal decisions. I think the final point I'd like to mention is that we are also considering the multi-objective nature of these optimization challenges, so we don't collapse the problem to a single objective. And we believe that this approach that we are working on has the potential to not only improve the user experience, but also lead to a reduction in capital expenditures, and make also possible minimizing the need for over-provisioning and prolonging the life of existing network deployments and infrastructure. I think that summarizes my slide.
Okay, I think this is the end of the presentation about the objectives of objectives and the progress of MAP-6G. And thank you all for listening to us.
Thank you very much, Tim and colleagues. I think we'll have some time for some questions, but I think, Nicholas, are you going to continue it further? And then we'll have a little quick summary of any questions anyone has for Tim, Ioannis, and Nicholas after the next presentation, which puts a little bit more context on what we're discussing here today. So, Nicholas, over to you.
I go, okay, you can see my screen, no?
Yes, I believe so.
Okay.
I think, Isis, if you could just remove Tim's screen, that'd be great.
Wait, let me try it again. Does it work now?
Yeah, looks good. Go ahead.
Yeah, great. So in the few minutes that are now for the slot, I will talk a little bit about things that we've been thinking about technology that we're building in MAP-6G and how this could be related to Telefónica's products or use cases or things that we have at hand. So the first one that I want to touch is what I briefly mentioned earlier, which is the further learning as a service. So this is an ongoing proof of concept that we're also exploring for further building and exploration of possibilities. Just to mention a little bit more, highlight the functionalities of this service. The idea that you have, for example, different devices. You have a central sort of server, FL server, cloud computing server. You may have edge devices that are sitting on antennas or beyond. And during the further learning process, you send these model updates to the server, and you receive back a global new model. And this model can be used locally in these red boxes where you have the Flash agent. Now, at the same time, you can have some other scenarios such as smart TVs, for example, with their smart remote controls. You can have the Aura Movistar Home device sitting in the house, maybe some edge device, and you may send a command from your remote control to the Movistar Home box. These may need further understanding because the model locally is not ready yet, and this gets transmitted as further building of the model to the server that receives back the new global model, and then it can be used locally for execution to the TV. So this could be a scenario where you have the cycle locally between the remote control, the Aura box, and the smart TV. But if the model cannot interpret your command, it may need to go further. Now, all these things would not be useful unless you have some API that allows third-party services to interact with this and allow the third-party services to train models using the further learning paradigm on devices such as the user devices, as well as edge devices or Telefónica devices. So that being said, this brings me to the next point, which is the home as a computer concept that we introduced a few years ago and presented in the Mobile World Congress. And this is a whole ecosystem that allows, first of all, it builds on top of the Ford platform initiative that we launched a few years ago, and allows the access to the various types of data that the users produce inside the system. And on top of this data, you can build a lot of applications. You can use them to train models that can help the users. I just mentioned here a few examples that are already in the system as we speak. If you go into the Living Apps system, you will find a lot of this. For example, for shopping, entertainment, such as gaming, you can find applications for education and culture. So there are different types of courses that you can check out. lifestyle and home. So you can do purchases, you can interact with such services that offer these type of products, podcasts, and of course our own Movistar apps. So the previous ones that I mentioned are a lot of third-party type of living apps. We also have from Movistar several applications that are deployed in this ecosystem and can help the users. And all these things you can do basically from these Movistar home devices that I mentioned that are in your home. It could be your smart TV, it could be this Aura box, and so on. Moving on, just not to be late with time. Furthermore, Telefonica is considering a lot of different settings that 5-6G type of technology can be used, and I can definitely foresee the privacy preserving AI aspect that we are working in MAP-6G to be useful. So starting with the whole concept of how do you make use of the higher speed, higher bandwidth in different scenarios. So I have here the autonomous ground vehicles that can help companies in warehouses. We have remote assistance where you can help you can help factory workers or technicians. Drone deliveries that we have already started seeing companies using that, as well as building 5G networks that are protected and they provide this privacy in the setting. Then we have some other examples of use cases that 5-6G type of networks can help, and starting with mobile insights. So these are different types of insights that can help companies that are interested in the mobility of users to perform predictions, to figure out where more resources may be needed, maybe where to build new shopping malls or new service stations. We have tourist insights and geospatial insights. Again, this is a similar type of concept, but for a different domain. Furthermore, computational computing, this is also something that my team is working on. How do you protect the computation of the models, especially when they are executed in the cloud or partially executed on mobile devices and partially on cloud services. And finally, ideas such as identity protection. So how do you construct identity fingerprinting of a user to use it for their own protection through the data? Anti-distributed denial of service solutions, which is something that also Telefonica is looking into. Cybersecurity protection across the board. So this is a more general concept. Telefonica is investing a lot in providing B2B services to companies that need such protection. I have more examples, but I ran out of space and time, and I have also personalized health. You can also think about personalized education and so on. So all these type of examples allow us to imagine how fast 5-6G type of networks can be used for the better well-being and benefit of the users, but at the same time raises the question of how do you protect the privacy of the users that are being involved. These users may be end users, it can be intermediaries, it could be companies. So there is a lot of concepts here to keep in mind. It could be personal data or non-personal data to be protected. And the technology that we're building inside MAP-6G, especially from the point of view of privacy preservation and scalability, is will be important, will play a crucial role in the development of this kind of use cases. I guess that's it from my side. I hope we saved a bit of time from the schedule.
Thanks a lot, Nicholas. And just to say thank you again for bringing kind of to the fore about why privacy is needed as we go into these advanced applications. And the fact of the matter is the risk and trust is the two things we need to work on there and make sure that everyone is comfortable and able to bring into their tech stack, but also into their applications in that way.
Yeah.
I think with that, I'm going to hand over to Jörg now, because we're going to take a shift away from looking at privacy and machine learning and moving a bit more onto, if you forgive me, you're talking a bit more about hardware and further applications within RISC-6G. So Jörg, if I can hand over to you, and then we'll have followed by Francesco.
Excellent. Sounds very good. Can you see my screen?
Yes, go ahead.
Perfect. Okay, so since it's only 15 minutes, I'll stick very much to the high level. And then, of course, we can drill down a bit more into the details of what it actually technically is that we're doing in the panel that we have later on. So the motivation and the application scenarios have to a large degree already been sort of tackled in the previous presentations that we've seen. The research that we do in RISC very much looks into augmenting the mobile network with additional capabilities such as localization and sensing. And now that is like research that has been going on for a long time, but it's becoming very relevant now because now the hardware capabilities of networks are becoming sufficiently high so that a lot of use cases can be covered that require such sensing, right? Where we've been in the past, it was very difficult to get networks to give you accurate localization or sensing information. You had to operate them in very specific ways. And now it's becoming much, much easier just because networks are becoming so much more powerful in terms of their capabilities for communication that then also lend themselves to better sensing characteristics. Now, in addition to this, we also use intelligent reflective surfaces or reflective intelligent surfaces that help to further increase both the network capabilities as well as sensing opportunities. Those are basically surfaces that are not active transmitters, but basically help to shape the communication environment by providing additional reflections for the signal. Now, at the moment, because this is happening, there's also a lot of, because like the network capabilities are increasing, there's a lot of interest from industry and from standardization bodies. So we also see that localization efforts are intensifying in 3GPP in the current release. And then future releases directed or targeting 6G, of course, are expected to put a much higher focus also on the sensing capabilities beyond just localization. And similar to mobile networks and 3GPP and ETSI, also in the wireless local area network side with IEEE 802.11bf, there's a lot of standardization efforts in this direction. Now, what we target in RISC-6G is 6G mobile networks with vastly larger number of connected devices, significantly high performance requirements, much higher network and device heterogeneity due to that, right? So some devices, some networks will have extremely high performance. Others might be targeting IoT scenarios that have very high device densities, but then the individual devices might be much less powerful, much less capable. And as I mentioned before, support for detailed object and environment sensing in addition to the communication. And now to get to that point, there's a number of crucial new technologies that we're trying to integrate into mobile networks to provide this environmental sensing and new communication capabilities. At the same time, it's very important that all these new capabilities in the ideal case do not vastly increase the network energy footprint and hopefully might even be able to lower the network energy footprint by operating the network in a smarter way through all the additional information that we obtain through this sensing. And here, as mentioned before, we want to harness intelligent reflective surfaces, visible light communication, RF backscatter, and other technologies. Now, just to give some very brief overview of the structure, it's similar to what we've also seen for MAP-6G. One thing that's critical for us is these are technologies that are still at sort of the research stage, and development stage. And use cases aren't quite there yet. And yet it's critical to understand what those future use cases will look like. And of course, there we highly rely also on insights from our industry partners in this project, just to understand the constraints that we have and the quality of servers or the right key performance indicators that need to be achieved for these technologies to actually be useful and suitable for mobile network integration. And now how to achieve that network integration, how to enable those new technologies in the mobile network is critical. And the current architectures are not always ideally suited for these kind of tasks. And in the project overall, we have a very strong focus on practical experiments because we believe that it's very critical to look at sort of prototypes, look at test beds. They very often point to important practical concerns and practical ways of how such an integration can actually work. If you just stay on the theoretical and simulation side, very often you might overlook something. So some brief example results. One of the aspects that we're interested in is multiband localization. For example, millimeter wave, as you might have heard, allows very high location accuracy, and millimeter wave communication, so communication at very high frequencies, is being considered for these future networks. In fact, millimeter wave is already being integrated into 5G networks, and as we go up in frequency, there will be even higher frequencies in future 6G networks. We will be able to achieve higher communication rates. But at the same time, also, if you use these high frequencies for localization, you can achieve extremely high accuracy. Now, one problem there is when you have a line of sight link, everything works perfectly, right? When the two devices can see each other. Now, if you have a non-line of sight link, and there's a simple example I've drawn here, right? So if you might have an open door, you might have a path that goes through where the door is, right? And that's reflected off of the wall. And now if you estimate the distance and angle at the receiver, right? What you will estimate is a wrong position for the device because you don't know that this is a reflection. And this is something where purely at millimeter wave, it's very hard to detect. A system that we build uses multiple frequencies. So it also uses lower frequencies where you penetrate obstacles. And for that reason, at lower frequencies, you can see that there is another path through a wall that directly goes to the receiver that is not available, not visible at millimeter wave frequencies. Now, by looking at a location system that uses all the different frequencies, you can resolve such ambiguities. And so we built a location system that uses sub-6 gigahertz to understand when the millimeter wave information is accurate and when it is not accurate. And we believe that is something where for mobile networks, of course, you will have new frequencies become available as network deployments for 5G and 6G roll out. The lower frequencies will not go away. So you will have such multi-band networks in any case, and then they provide very interesting options for localization. Now, at the same time, you can track objects. For example, here we have a simple example where we look at a transmitter, a receiver, and the multipath environment, right? So there are reflections in the environment that are created by objects, and we can track that. This allows to track how those objects move. And what we looked at here in this specific example is that how many links do you need in an environment to provide accurate object tracking? And what you can see here is that the accuracy you can achieve was very high, right, down to a few decimeters, but you need a number of links active in the environment to be able to track objects everywhere. Otherwise, you see objects only part of the time because reflections will not always reach the receiver. And now lastly, this can also be used to not track objects, but the environment itself, right? For example, understanding where the walls are in an environment through simultaneous location and mapping. This has been done a lot with LiDAR and radar and other such technologies. Of course, there are lots of vision-based approaches with cameras as well, but we can do the same thing with wireless devices, and especially millimeter wave, which is very high accuracy, lends itself to accurate angle and distance estimation and thus environment mapping, right? And this is an example here on the right-hand side where you see a device that's moving through the environment, is connecting to different access points. So the green dots are the ones where the device is moving, and the black crosses that you see are where reflections are coming from in the wireless environment, right? And that allows you over time to better and better estimate where the walls are or where objects are, right? What you see at the bottom here, for example, those are not walls, those are computer screens, so you can even detect objects in the environment. And lastly, what is highly interesting also is towards the sensing that you can typically do with very accurate radar systems. And now you no longer need radar systems with new technologies, especially millimeter wave, especially at millimeter wave frequencies and very wide band communication systems. You can achieve the accuracies that you would get with fine-grained millimeter wave radars just from your communication system. Sort of one direction we are pushing the work in RISC-6G is fine-grained microdoppler extraction. And just as an example here at the bottom right, there's a microdoppler spectrum that we have extracted through just observing communication packets of a person walking. And what you see here is a sort of a solid line that reflects the torso, which has typically a strong reflection, but you also see these little frequency variations in the Doppler that come from the arms and the legs, right? So these little spikes at the top and the bottom, those are the arms and the legs moving at different speeds compared to the rest of the body. And the interesting part is that sort of how to do this with very good radar systems, that's very well understood. Doing this with communication systems that operate in a very different way from radar systems, it's interesting to see that this is in fact feasible. And the accuracy we achieve there is very high, right? So we had even scenarios with many persons in the same room at the same time doing different activities, and you can resolve all of this very nicely, right? You see there's person 8 in a certain spot waving arms, there's another person walking around. All of those are partly occluding one another, and still you can track them and determine what activities they are carrying out based on the microdoppler spectrograms that you see, right? So microdoppler spectrums are very sort of person-specific and activity-specific, so you can identify persons and you can identify the activities that that person is carrying out. Okay, now I'm having trouble with my slides. For some reason, it does not advance to the next one.
I was just about to move you on as well in time.
Yeah. So sorry about that, but since we're running out of time, yeah, my PowerPoint crashed. Nope, completely crashed. Apologies. But with that also, since we're out of time, let me maybe have a few final remarks. So on the one hand side, we are looking into sort of how to integrate all of this into the mobile network architecture, right? Sort of one thing is extracting information from access points and base stations and then doing this localization and sensing. But at the same time, you need to store and process that information in the mobile network. And so what architecture can efficiently do that? How do you need to modify the mobile network architecture to do this in an efficient way? And at the same time, now it seems to be recovering. Right. And at the same time, the privacy and security implications that we've heard about also before, right? Sort of you want to run machine learning on this. Now, the first question is, how do you extract that data in the first place? Where to run the machine learning? And how to do this in a way that's privacy preserving for the user. Those are very interesting, important questions that we address. And with this, let me conclude here. Thank you very much.
Thanks, Jörg. And what looks almost like sci-fi is actually a reality. And as you say, the main thing is that we need to start also making sure that it goes in tandem with the work that we're talking about in MAP-6G of that privacy and trust element, especially as we get more and more interesting in how we're using our networks. And I think the applications are going to be enormous in this area as well, long term. Great. And I think then to follow up on this, I think on that point, Francesco Devotti from NEC will be giving us an overview then of how does that actually translate. So when we're talking about the sensing of the networks and then using different type of hardware, and as you mentioned, across different bands. How does that actually translate now into the future? So maybe Francesco, I invite you now to give us a quick overview.
Hi, good morning, everyone. Can you see my slides?
Yes, go ahead.
Okay. I'm Francesco Devoti. I'm a senior research scientist at NIC Lab Europe, and I'm going to present you some potential application of the technology we are developing in the RISC-6G project. So, starting from nowadays, basically we are in the rollout phase of we are starting the rollout phase of the new 5G technology. And we can already see the unprecedented experience in communication and localization performance that is conveyed to the end users. However, we have to balance these technological benefits to costs and drawbacks that this technology is providing. In particular, 5G and beyond 5G, 6G indeed. Base stations will exhibit unsustainable hardware costs, and introduced transmission solutions will be highly complex and in turn power hungry. Moreover, as anticipated before, we will rely on higher frequency bands that will directly influence on the propagation property of the communication themselves, and they are impaired by the huge material penetration that will require in order to have service coverage to base station densification process. So in turn, it will again increase costs of deployment. A potential solution of these aspects relies in this new technology, which is called reconfigurable intelligent surfaces, that we are currently investigating in the project. And as mentioned by Yor before, these devices are basically passive devices that has the capability of control how the signal propagates in the environment. In particular, they can be configured in such a way the signal is steered from the transmitter to the devices in the intended direction, and cover areas which are unreachable, and provide opportunities, for example, to improve the sensing capabilities of the network. Getting back to what is currently going on right now in 5G network, we have this communication paradigm where the propagation environment is seen as a black box. So devices are basically being optimized in such a way the communication is adapted to the current propagation conditions. And this is done by means of transmission techniques to overcome basically the impairment that the channel is providing to the communication itself. Moreover, we see that communication are working very good when there is the so-called line of sight condition. So when device are directly can directly see the transmitter, so that they can have a higher, let's say, received power and get higher communication performance. With the reconfigurable intelligent surfaces, instead, we can move forward and get this programmability in the environment to obtain the so-called smart radio environment. In particular, we can, let's say, control how the wave propagates and adapt the channel itself to the communication. So we have this new optimization variable that comes into play together with the standard, let's say, transmission techniques that we have nowadays. And this comes to several benefits, because we can deploy these devices, which are passive and particularly simple from the hardware point of view. That means that they are quite cheap to be produced, and so we can deploy many of them in order to improve the communication capabilities and sensing capability of the network. So we can scale up the number of devices that are deployed very quickly. Moreover, they are passive, so they come with a lower power consumption compared to traditional access nodes. So we have also an improved sustainability in terms of energy consumption as well as costs. Here I'm showing to you an example of such device, and this is a prototype that we have developed in our labs. It, as you can see, it comprises a set of antennas that are passively reflecting the signal, so they don't add any power to the signal. They are just, let's say, controlling the reflection of the impinging signal on the surface. This prototype works at 5.3 gigahertz. We are working on another one that works at lower frequency, but we're working as well on a prototype at millimeter wave frequencies band. And let's say we don't have active components apart from this controller that is in charge of the configuration of the surface. And as you can see, the power consumption is extremely limited. Moreover, we can, let's say, reconfigure the channel really quickly, as this device requires only 35 milliseconds in order to completely change the configuration of all these unit cells. If you're interested in more details, I leave you here a pointer to a paper that describes all the technical details behind this board. What we can do with those devices, one application is, of course, the coverage enhancement. Here it's a practical example that we have faced recently, where we consider the coverage, the 5G coverage in the Rennes-based railway station in France. In particular, this station comprises two 5G base stations, and as you can see from this plot here, we have some communication dead zones, so areas in the station that are not well covered by the signals, and so where user devices are experiencing lower communication performance. One option here to improve the connectivity in those areas is, of course, to install another base station, but this means that we are going to have high costs because of the new hardware that we are deploying, and as well as we have to, of course, control these new base stations, so we're also going to increase the operational costs. A possible solution to this problem is to, instead of a base station, is to install reflective reconfigurable intelligent surfaces in the area. And in this way, we basically would be able to, let's say, increase the coverage in the station without requiring to install additional base stations. Moreover, we will provide this new connectivity capabilities in the area without increasing the power consumption, because we are doing it with passive devices. Those passive devices, together with let's say the increase of the communication capabilities, can be controlled, so we can use them also to perform additional operations, as I will show you later. But firstly, here I'm providing you some heat map with numerical results showing that with the few RISs in the area, we can improve the SNR in the dead zones that I was mentioning before. But let's see what we can do beyond this communication enhancement by simply deploying RIS for communication. Here we have this example. It's a field trial on localization use case, basically. This work has been done in collaboration with Stellantis and team. And here, basically, we deployed in a smart factory environment RIS and base station on the network side, that are providing communication to this robot, this AGV, that can move freely in the area. In this case, the RIS are used to provide better connection to the AGV, so they are controlled in such a way they steer the signal towards the robot that is moving in order to provide communication. So basically, we are controlling the network only for improving communication performance. However, by knowing the configuration of the RIS, we can do something more. So we can take this information, so the angle that has been set in order to reflect the signal from the base station to the robot, from the to deploy the RIS, in order to triangulate this angle and locate the AGV moving in the smart factory environment. In this experiment, we achieve a performance of about 30 centimeters of accuracy. Another and the last use case that I want to mention here is about privacy preserving. And basically here we are considering how to use RIS in order to improve the privacy of room service. So in this case, basically we want to create some areas wherein the privacy from the wireless perspective is maximized, in a sense that we want to shield this area for preventing communication from the inside to the outside, and vice versa. In this way, we have a twofold benefit. So basically, we have that the information that is exchanged wirelessly within the room does not go to unwanted listeners, let's say, from the outside world. So we are preserving the privacy of the room, as well as by shielding from the outside to the inside, we are also improving, let's say, we're also reducing the level of interference. So we are improving the communication performance again. This use case here we are considering, let's say, this indoor environment, but can be seen as useful, for example, in healthcare, where we want to, for example, shield areas of hospitals from unwanted penetration of electromagnetic signal that might impair the operation of healthcare devices such as pacemaker or other devices that might be, let's say, being affected by external factors. Mm-hmm. This concludes my presentation. I was quite quick because of the time constraint, but now, if I'm not wrong, we have the Q&A session, so we can dig deeper in details, if you like. Thanks a lot.
Thanks, Francesco. We never have enough time in the agenda ever. But thank you for giving us the overview there, especially of how we can translate when we talk about RIS and actually how it gets put into implementation there. So we have a couple of minutes for any questions anyone would like to address to any of the speakers we've had. So to Tim, to Johannes, to Jörg, to Francesco, and also to Nicholas. So any questions anyone would like to ask, you can raise your hand. I know we had a question early on related to the privacy approaches, but I think that's been covered already. No, if that's the case, then I think we'll move on then with our agenda, and we've managed to then recover time. And as you say, anything that comes up into your mind, please do put it in the chat. So we go on to our...
has a question. Yeah.
Sorry, Nicholas, was it a thumbs up or a hands up?
Thumbs up, but okay. No more questions. Thanks.
We're safe for now. So thanks very much, everyone. And moving on to the next part, we'll have our first panel. So we've had lots of discussions there today already about what the different technologies that we're talking about that are forming part of the future networks and the current networks as we're going on. So the first panel that I'd like to introduce you to is related to the adoption of these different technologies and kind of how is it that we're able to work with the technologies to meet what I think Guy already covered, which was kind of the constraints of what's being met within the environment of the user and the intermediaries as well. And if I can summarize quite concisely from what we were discussing, really we're discussing the challenges that relate to price. So the cost of delivering the new infrastructure and the installation and the capital expenditure. We're talking about the power. So the increased demand of the networks and the increased power overall want to have lower power applications in this area. We're talking about the physics. So the fact is that we have higher frequencies, they travel less distance, and we have more dead spots, more blind spots that we're talking about. And then finally, the areas around privacy, and all this embedded in the fact that we're able to add in better areas in these networks. So I'd like to invite the panel that we have here today. So we'll be hearing from Jörg and Francesco, who you've already met. And I'd like to then invite Thomas Hahn, who's the chief expert for software within Siemens, among many other different roles that Thomas takes. And he's going to do a quick introduction to who he is and a short overview of from where Siemens, and especially within the manufacturing context, the challenges and the drive is coming for the adoption of new technologies, new networks in this area. So maybe, Thomas, if I can ask you to take the floor there.
Yes, and I hope you can hear me.
Okay. Yes, we can hear perfectly.
Perfect. That's always so a warm welcome from my side, and many thanks to give a little bit and brief speech and participate later on the panel, like you mentioned. And Brandon, you are showing similar slides, I think. You're okay, perfect.
Yes. Yeah.
Perfect. Yeah, let's say the following. Also, you know, as Brandon said, I'm chief expert or fellow inside at Siemens, taking care for technology aspects, broad area, also not also focused on manufacturing domains and domains where Siemens is inside, or Siemens AG, also not the healthcare expert, but more the manufacturing expert. And I want to bring you some kind of your views about from the application side. As you know, you have seen from Francesco one example before regarding Stellantis. You see here also the HEV on the slides is also one of my examples. What I want to do is here really to give you some kind of your aspects in different view, more from the application side and focus on manufacturing. So, and to be honest, I'm not the 5G or 6G expert like you are, but maybe hopefully giving you some kind of insight why we are from the application side are interested in 5G and also have some kind of outlook regarding 6G and always with examples what we want to achieve, what are the added value, what we want to target with this technology. And you will see here some examples. I will not go into detail, but as you may be aware that, or you're very sure you are aware of the data economy, to get value out of the data, to look for new business opportunities with data, and is one of the hottest topic, or the hot topic in manufacturing domain. And Brent mentioned that I'm active in different areas. I'm also active in manufacturing X, where we exactly targeting to get value out of the data, to improve your, let's say, existing processes, to make processes more sustainable, but looking also to new process opportunities, new business opportunities, and also, maybe to add, when you're speaking about the supply chain, where we really look at a wide area range to look data to make our supply chains more resilient. So this is what we are targeting, what is driving us, and only why we are, let's say, in the 5G environment. And I will have two additional slides, a little bit 5G and outlook, what we're expecting towards 6G. Only to give you some feeling about One is regards this AGV topic. Stellantis example mentioned from Francesco before, similar in our topic, meaning also what Jörg mentioned regarding accuracy and so on is driving us. So, or when you have seen in the upfront this remote service activity that you have on a one channel, mixed data in a wide area, a wireless environment, which are driving us and makes this interest for us. And only to make it very short, Siemens is offering also product families in this area, end-to-end and access points, as reading all the infrastructure, but always focused, let's say, on a shop floor domain, where we're inside, or manufacturing domain must not only be a shop floor, but manufacturing domain. So maybe now, just Brandon, jump over to the next slide. When you're looking a little bit about the capabilities from our perspective, so you see on the left side and on the right side, these two triangles, more, let's say, a profile which is used in the public area. On the right side, you see a little bit our profile with respect to the 5G capabilities in our industrial or manufacturing environment. And what is interesting for us and needed for us, interesting for us is enhanced mobile broadband. As you know, I mentioned before, mixed signals, that you have machine data and also video signals over the same media, also in a wireless environment. Not to forget the topic we addressed before, to accuracy, what was touched, especially from Jörg and Francesco before. On the other side, also this latency topic. When you are in industrial domain, latency, to know when a process is starting, ending precisely in time, real time, guaranteed real time, that was driving us. And that's the reason why our triangle, which you see on the upper right side, is a little bit shifted to this right corner, and not so much in the massive machine type communication. It's interesting also when you're speaking about between factories and to get sensors around or the outside of the shop floor, but our main focus or main, let's say, requirements is shown here more on the right side of this triangle, like explained before. So this is, let's say, for 5G. When you're just going one slide ahead, regarding to also have some kind of a little bit of deep dive about application. You see this again here on the right side, or on the left side of the slide. Some example of application could be augmented reality. Think about my words about the mixed data, access and maintenance, guided vehicles, as said before, mobile robots was also mentioned before. And exactly when you're going to this latency topic with a closed loop control, and you see it twice, you see it here for the factory automation versus really in a short time, fast reaction, guaranteed reaction. And when you're going more to the process industry, this is requirement is existing, but not so significant, because when you, don't ask me, melting some kind of material, so the time to react is a little bit not so high in comparison to a factory automation where we have to control maybe a fast running machine or conveyor belt or something else. So it's only to give you a feeling about where we are at the moment. And when you're now looking to the right side, and you see here, I think you're more aware of this, like I am. As said before, I'm not the top expert for 6G and 5G. But nevertheless, when you're looking at this green marked topics, immersive communication, to enhance this also in the 6G environment is essential. I'll give you only one example. I mentioned mixed data, but when you're seeking also about an industrial metaverse, where you have also this interactivity with video with simulation, with argumentation, and the capabilities to get, let's say, the network capabilities in area is key for us and relevant. The next topic, when you're going to the right lower corner, hyper reliability and low latency, is obvious. Time sync operations and so on is key in manufacturing. And as I said before, also in the different domains from process to factory automation could be relevant. And this massive communication, this is also a topic which is needed. When you go now to the lower part, ambiguous connectivity, also when you have this ability to non-terrestrial communication, think about my words about resilience in supply chain or going out of the shop floor between factories, between buildings is becoming high of interest. And, when you go into the right side regarding AI and communication, to get value out of the data, because at the end, on the application side, we have the data access, but we have to produce something to create impact. AI and communication and supporting this, let's say, is on the spot at the moment, which we are doing on with targeting. So it's a very brief perspective, a little bit from an application side, and highlighting also some topics what you, for example, Francesco, with this example mentioned before. Many thanks.
Thanks very much, Thomas. And I think that kind of gives that overview of what's the pull factors that we're talking about, kind of what is it that's actually needed, what is it that industry is looking for, and what is it that we need these new networks for. Just before I kind of ask some questions to the other members of the panel, reflecting on the fact that these are kind of the leading use cases, these are the opportunities that we have before us. This is a constant investment. And if we take manufacturing, for example, it's a constant need to bring in this new technologies, these new systems, and these new solutions. What are the kind of challenges that you've seen, or maybe, because I know you come from the software part, so you're relying on the infrastructure in place, but what are some of the challenges that you see when industry, Siemens clients, for example, are needing to upgrade the infrastructure? Where do you find the kind of the main hurdles, or where have you seen that in the past?
In general, let's say, and you addressed me as Siemens, for sure we have here the link, it's a good link also to the partner from the communication industry, and we make also some code development and so on. I think it's not the issue, or it is an issue, but it is targeted. But the challenge is really scaling up in a broad area. And to be honest, I have spoken about manufacturing industry, with 5G and 6G, where you have a lot of other verticals to address. But in this case, the challenge is really the scaling up towards small and medium-sized enterprise to get it in a broad area available, the technology available. And the second issue is, besides the scaling, also what are the new business opportunities which we can target with. This is when we ask me what is the top 2 highlights topic. It's scaling up a small and medium-sized enterprise, because these are the backbone of the manufacturing. Don't ask me, 80 or 90% of the manufacturing GDP is covered from small and medium-sized enterprises, also not from the Siemens and others of this world, but this is our customers or our partners, and scaling up in this area is key, and new business opportunities. Besides the fact that we have to target sustainability issues, resilience, but only to highlight on these 2 topics.
Thank you. And I think maybe Jörg, I'll kind of hand over to you now to talk about how from the point of view of the tech development, this idea of scaling up is in, there has to be the business case. And how do we help build the business case for the 6G networks now, and including 5G networks as they exist, so extending those networks now, so that those SMEs, for example, can justify very easily why they need to incorporate the new capital expenditure that we spoke about, and also ensuring that we're able to improve that return on investment of future networks. So maybe you have an idea, kind of, you were talking before with me about, making the networks work harder, but also making them more efficient. So I don't know, how are you seeing this from your point of view in ways of making it more market ready in terms of the technologies that are going in now that will be the networks of the future?
So I'm very much from the research side, so I see this very neutral. And of course, there's a lot of sort of political discussion where obviously they're very sort of vested interests, right? To see 5G succeed, to see 6G succeed, to integrate verticals and so on, right? There's a lot of money in those networks and interest in having those networks heavily used. Now, from a purely sort of what's likely going to happen and sort of in a completely neutral way, I think that's a very, very good question that we still don't have a very good answer for, right? So the question is always, why should mobile networks do that as opposed to all the other options that you have, right? For example, with the sensing, the question is, do you use a mobile network to sense the environment, or do you use cameras, or do you use a radar, or whatever other sensors that are well understood in manufacturing, right? Pressure sensors, temperature, and so on, right? Sort of, there are a lot of existing solutions. So the only way a mobile network is going to break into that space and is going to be used there is either because it leads to substantial cost savings, and they have to be substantial, because if you just save a little bit, you stick to the old, well-known, well-tested approaches, right? So they have to either be substantial savings or things that you simply cannot do in any other way. And that is something where I think there are sort of ideas on why and where that might happen, but we still lack the clear use case where we say, okay, here it's crystal clear, you need a mobile network to do this, right? So the hope is, of course, you might have large factories, for example, where you need mobile connectivity anyway, because other connectivity solutions are not enough, right? For whatever reason, your local area networks, your wireless industrial networks, and so on, do not provide you with the right services. And of course, there's a big advantage for 5G and 6G networks, because they are at scale, right? The device costs they have, the capabilities they have, just because it's produced for millions and millions of devices, that is clearly something where doing this with industrial networks that are much more special purpose, you just don't have that scale. So you might have a cost advantage there if all the other KPI match. And then it has to be something where your normal, if now we're talking about the sensing aspects, your normal sensors are too expensive to deploy them ubiquitously. And you have your network already deployed there because you need it for communication purposes anyway, right? If you're talking about extremely expensive machines, then adding a 50 euro, 5 euro, 50-cent sensor is going to be the right solution. If it's something where you need this ubiquitously and you don't want to deploy sensors everywhere because the use case is not that, well, not providing you that much revenue, right? That might be an interesting case for where that might be happening in factory automation. Now, the other area where I clearly see that is no network is as ubiquitously deployed as the mobile network. So if we are talking about sensing at city scale or at country scale, well, yeah, theoretically, you could cover a country with video cameras or radars or whatever you want, right? But it's just like the costs are in no proportion to any use case you might potentially have there, right? That's just not going to happen. Whereas mobile networks are already deployed there. So if you're talking about city scale sensing, and not just in the sort of very inner city where maybe you already have video cameras, but you're trying to do traffic monitoring ubiquitously, right? Throughout sort of very like many large scale urban areas, right? That is something that mobile networks can provide. Now, what's the use case? Who's going to pay for that? Well, city planners, cities themselves, right? They need to understand better how their infrastructure is used, maybe transportation services and so on. But again, right, sort of that's something where I think we need to understand a little bit better the specific use case to understand when would a mobile operator be willing to do that, because the money they have to invest in their network to enable this. And it's not just, right, the base stations are already there, fine. But now you need the whole infrastructure to manage that, to make sure you can extract the data in a privacy preserving way and so on, right? Sort of then the engineering challenges are clearly like manageable, but they're there, they cost money, right? And then when would you have somebody willing to pay for that data that makes that a compelling business case? I think that those are sort of the potential business cases are there. And the really interesting question is now, which of the ones from a practical perspective is at the point where the cost benefit, right, works out to make that happen?
And I think you picked up on the point there, and especially in this context, when we're talking about networks and infrastructures, better is not enough. it has to be substantially 10 times better, 10 times cheaper. Or as you say, and I think this is something that we're talking about, is that we need to find those cases where we can build the business case that this cannot be done any other way. Because I think we have to figure out, and maybe Thomas, you might want to jump in here on this as well, is that we're not talking about greenfield sites. We're not talking about building new factories. We're talking about, or new cities or new whatever. We're talking about integration with existing systems. I think that creates certain challenges that we need to justify. And I wonder, is there something that we can do to work with these legacy integration systems? And I think already, Jörg, you mentioned the fact is multi-protocol environments or multi-band environments are actually more useful. So it's not about switching off the old, but maybe adding in the new. I don't know if anyone has thought there on that kind of around that legacy piece and that need to shift. Yeah.
Maybe to add on this, also what Jörg said, for sure, the scaling costs is a little bit interlinked to each other. When you have a bigger scales and the costs are reduced, and you notice that, for example, with 5G, to make the adaptation on the shop floors, there's some kind of reserved bandwidth where you can use this. And for sure, like I discussed before, and I mentioned this also, what is the businesses, or how to get value out or impact out of this. The second issue which we are targeting, you're right, you have a lot of brownfield applications, normally in greenfield, where you build up from scratch on a plain field, a new factory. It's depending on industry different, especially when you're looking at the process industry, where we have, for example, a huge chemical plant or something else, or a huge energy production unit, where you really want to have to optimize this topics, and you have to think about how you get now access to the data which you not imagine to measure. Don't ask me 10 or 20 or 30 years before where the plant is built. This could be also an opportunity where you can easily attach additional sensor wireless connected, because you can also put a cable to the different sites. And to be honest, this size of this shop floors are also very huge. So which is again against the cost topic. So this could be really on the brownfield. I've not touched this before, but you're right. This would be one topic to think about more heavily. And here, where you have maybe some kind of good access point for wireless connectivity to get the data, to distribute the sensor, to collect wireless data, and to improve and to impact the operation. That could be really, and this in this case immediately costs more cost efficient instead of wiring the complete big plant, for example.
And I think that brings into kind of the competing interest that we have, is that, we need our networks to have greater capacity. We want them to be able to handle, new areas, but we also have to look at our sustainability and we need to make sure that we're using less resources, that they are more efficient and more effective in their way. And I wonder, Francesco, from NEC's point of view, kind of looking at how 5G was kind of, if forgive me if I can say it, kind of like, it was about power. It was like a muscle car, it was getting that power, that horsepower behind the network that was needed in place. And now we're talking, okay, let's look at how we can make our cars more efficient. How can we work on kind of increasing the more elegance around it as we go towards 6G? How are you reflecting within NEC that kind of learnings from 5G experience, and how is that shaping the idea that the networks of the future will have to be different, so that the business case is easier to make? So how are you reflecting on that?
So basically, okay, if you see at 5G, I'm taking this as an example. So we had like the first attempt of deploying massively millimeter wave connectivity to boost a lot the capacity of the network at the end user, so provide extremely high rate to the mobile device, basically. And this, of course, if you have such a powerful infrastructure that gives you this, let's say, capability, then you will find use cases to deploy. So you can find new services that can fit this new, let's say, capacity of the network. However, this, let's say, millimeter wave usage was not followed by deployment, a massive deployment as envisioned because of the high cost. So getting back to what Thomas and Jörg were mentioning, so what we want to do here with the 6G is trying to, let's say, overcome the limitation that we have seen in the deployment phase of the previous, the current network generation, and use this valuable information of what were, I would say, the failures of the current technology to make the new one capable of providing these services. One important aspect, of course, is the cost limitation, because we have seen now, and we see now that power is an important aspect. So savings in terms of energy is extremely important, because we have recently had like shortage in energy, availability as well. And what we are seeing as researchers is, let's say, trying to find what could be new devices, new strategies that can provide the KPI from the communication perspective, so service provisioning, high capacity, and so on, to the network at a limited cost. So, for example, with RIS, we are exactly doing this because we have passive devices that are trying to, let's say, provide the connectivity that the network requires. At the same time, still from a research perspective, we will try to investigate on how to exploit the operation of these devices, and together with other sensor that might be deployed, to have like this interoperability between source of information, to have like this multimodal sensing operations in the network. And this, as Jörg was mentioning, is going to provide additional ways to deploy new use cases that we have still to think about. From the sensing perspective, again, it's a cost matter, basically, because if we have to deploy new sensors, then what we are going to achieve in terms of performance is a key aspect of consideration. But if the network itself, simply by operating in a communication perspective, can provide some sensing capabilities, for example, you can just use the signals that are transmitted by the devices to get additional information to the context. This is an extremely valuable additional aspect that the 6G network is going to provide, and this information that we gather from the new from this new network architecture can be directly moved to other services at the cost of an interface, basically. So we are not going to change the hardware, but we are going to provide information outside.
I think that's kind of the main jump that we've made in terms of networks, is the fact that we are able to virtualize them. And as you say, that also then means that the interfaces are able to be updated faster and quicker. I think that kind of covers really generally the discussion is around the fact that we need the business cases, because we can't just keep producing the new networks, but also we need to take into account that they're not being adopted in a vacuum. Because I think, you know, from a research point of view, we can do more with less. We can make the network work harder. We can make it more energy efficient. We can make it more, we can optimize the usage of it. But as you mentioned, Francesco, you know, we have to figure out, you know, how to reduce the electricity demand of it, make it simpler for the upgrades, and also make it much more a software conversation, rather than having to, and we know this already, having to send people out and to put things on different poles. And I think you mentioned as well the fact that if we look at RIS, I really think it's quite an interesting background here, because we're not talking about generic network functioning. We're now moving it into a whole other level. And I suppose, just to finish off on my last kind of point, and maybe I'll leave this to you, Thomas, is, we're not introducing this into a vacuum. The kind of final word is, how do we bring new network, and it's probably a last sentence because I have a minute left, is just kind of, what is it that research in these networks need to have aware when it comes to implementing a technology within a factory or within a site that's already existing? It's not just about distances and locations. We also need to look at what else aspects should we be looking at in terms of ensuring the successful adoption by the organization itself. What else any advice for everyone there?
Yes, to be honest, at the moment we have, let's say, a good opportunity, because all this needs, sustainability, resilience, and so on is on the spot. And, all these initiatives are starting up and running. And this initiative have a little bit, maybe a little bit more focus on a higher TRL level, also are closer to the adaptation. And I've heard also before words about impact and so on. And to establish here, and I think this round is one of the examples, to establish this link from research, from technology aspects, what is possible with 5G and 6G, and to adapt this. I think that what we have to drive. It was a relative general remark, but also with a positive message that we have the moment. I think the environment in doing this, or the mood in doing this, or the attitude, or however you describe this.
Excellent. Thank you. And I put you on the spot there as well anyway. So thanks very much to Thomas, to Francesco, and to Jörg for giving the opinions and thoughts there. And hopefully we kind of have a bit more view on where we need to go next in terms of taking this to the future. So thank you all very much. And then I hand over to Tanya to talk about how standards is going to be part of this story. Thank you all very much, everyone.
Thank you. And thank you very much to the previous panelists, because I think it's setting the scene rather nicely for what might seem quite a dry subject, which is standards. But we've already established that cost is clearly a driver of adoption, but standards are too. Depending on the industry that you may be operating in, standards may play a larger or smaller role. But the fact is that whether it's at the factory floor level or at the end user level, we all rely on standards to make sure that whatever it is that we have within our hands, or perhaps not in our hands, if it's something a little bit more virtual, actually works and delivers on its promise, it's fit for purpose, and we can use it safely. So having said that, I want to maybe take a step back, because there's another piece of data I think that really encapsulates why we're having this particular webinar and why we're focusing on some of the hardware requirements for the renovation of infrastructure in communications and sensing. And there was a really interesting fact from found out or published by Deal Room, who found that over the next 5 years, 60% of revenue in technology is actually going to come from hardware, and only 40% is actually going to come from software. By contrast, only 20% of VC funding went into hardware over the kind of like 5-6 year period. So there's clearly a gap between the attention that's being placed on more of the cyber, the virtual aspects, versus the need to make sure that we have the infrastructure in place so that those virtual, digital, purely digital, or cyber functionalities and tools and applications can actually be deployed. So this is going to be one of the challenges that I'm going to pose to my panelists. So could I please welcome Carlos Pedraza Rodriguez, who's Head of Business Development, Global Certification Forum, GCF, Dr. Ruth Sophia, who's Head of Competence Field at Fortis, Dr. May Salnadai, Senior Lecturer at the University of Essex, Dr. Flavio Thurillio, Senior Research Scientist at NEC, and as Brendan said, I'm Tanya Suarez, I'm CEO of BlueSpec. So welcome to you all, and thank you for joining me. So first of all, could I perhaps ask you, from standards are key to adoption. I think we're all agreed on that. If not, then please do feel to disagree. But standards are set at different levels, but for real kind of market adoption, they need to be agreed globally. So could you, each of you, I'll call each of you individually, could you please give your perspective on perhaps some of the areas that are related to RISC and to telecommunications and sensing, to specific areas in which you believe that European technology has perhaps an advantage over some others in relation to standards specifically. Ruth, would you like to start, please?
Yeah, sure. Hi, Tanya. So I would say that one of the aspects in terms of 5G and 6G, so of course Europe is already leading, because in terms of along with the USA, so in terms of deployment of 5G, I would say that we are well in the front. In terms of what, so 6G, to me, it implies that we have an interdisciplinary perspective, which is something that, so today we spoke about sensing and networking, network as a sensor, ISAC, etc. So these are fields that are indeed, in my opinion, extremely necessary. Jörg Widmer on the last panel also mentioned that in addition, so the sensing capabilities, they will come not just from cameras, so from a very diverse devices that we have on the far edge. So this implies that we have sorts of some knowledge and some advantages here in terms of the device-to-device communication, because these are aspects that have already been worked upon in Europe in different initiatives, such as so 5G PPP and now 6G IA. So I would say this would be sort of a differentiator. One of the things that you mentioned in terms of standardization would be, so to me, in my opinion, standards, despite the fact, of course, that we can place this in countries, they are led by industry, and the European industry is already leading in this aspect. So I would also put it on this track. The standards are led by industry, not necessarily associated just with one country.
Thank you. Carlos, would you like to provide your views on that, please?
Yeah, sure. Hello, everyone. So the reality about the European industry, it is that it comes from a leadership position in the early 2000 with the second generation. Then maintain a certain level of leadership in 4G, but in 5G, this leadership was taken by other geographies, but put much more investment on making it happen. But I think that a lot of lessons have been learned in the industry, and specifically the one about fragmentation. Fragmentation of the spectrum, fragmentation of the markets. That is one of the things where the European industry is taking a lot of care on making sure that we get in a better position moving forward. Because it's not about human resources, it's not about experts in Europe, it's not about companies, there are plenty of them. It's about being focused on achieving results that can be used all through the markets. So I think in this situation, in 5G, there is a lot of things that have been done. Others have been quicker on making the market available for everyone. But on 6G, I think they are considering these aspects from the beginning. So I think that's relevant.
Thank you, Carlos. Great points there. So we've had leadership before. We've lost it. We're now hopefully on track to gain it again, as Ruth was saying, now with 6G. But we need to address things like fragmentation. It's not a question of not having the skills or having industries that are capable of leading this. Maze, what's your view on this?
Hi, Tanya, everyone. Yeah, I agree with both Carlos and Ruth. I think the point in Europe and the advantage that we have over other competitors is that the challenge of fragmentation is something we have to deal with. We don't have the monopolies that exist elsewhere. And provisioning 6G in Europe means that we will have to address the challenge of fragmentation and federation across multiple actors. And that puts us in Europe in the forefront to develop standards that are closer to being adopted globally, because if we can address federation within Europe, then translating that to federation globally is just the next step. And so I think that from Europe perspective puts our industries in the leadership, because simply we are not going to be able to deploy 6G otherwise. So we are going to have to address the challenge, and that's in itself is an advantage. In terms of areas, I think one of the key things that has been emerging in 6G sort of strategic planning is the embedment of AI within 6G to enable smart services, to enable holistic sensing and communication, etc., etc. And soon enough, we started realizing that AI brings novel challenges, particularly with the dependency on data. And so I think one of the key areas, in my opinion, that will need to quickly become under standardization is first of all, what are the rules of engagement across different actors that enable federation? And what would be the models for data to be exchanged to enable sustainable AI embedment and robust AI services within 6G? That goes hand in hand with sustainability, with which the other speakers have quite eloquently highlighted. So that's in my view, yes.
Thank you. Great introductory remarks again there, Maze. Thank you. Flavio, now you're from a Japanese company, so you have to navigate this collaboration between different world regions and balance what might be more favorable to one region versus another. So what's your view on this? Where is it that Europe really does have to pay more attention?
Yes, thanks, Tanya. So hello, everybody. So yes, from to bring this exactly on this perspective, also from collaboration. So I am based in Europe, but like I collaborate a lot with Japan. So what I see is that European, let's say, standardization body in general, the directions are towards this data-driven approach. This is the data-driven society. So like towards this digital twin and metaverse, towards this digital society. We see like in Europe, let's say, initiative and projects like Gaia-X, and then like implementation driven approach like IDSA and Fireware. And similar, I say this is on a parallel track is happening in Japan with the Society 5.0. So again, like bringing the society in the digital world, and for towards also these sustainable development goals from UN. So like towards the goods of society. So saying that, I mean, like we see this that the basic driven is like the basic directions is driving the standardization is towards the putting together data, and that with different means of technology, so mobile communications, but also like optical network. This is also some directions that we are seeing in Europe as a like a main driver. So we see that towards these directions for the society, there is also like the driving the industrial and market appearing towards like the putting together data, and towards like the creating applications that are generating these new society, and in order to have data putting together. The major thing is like to have these digital twin or metaverse in the sense of high fidelity replication of the society in the digital world. That means putting very high requirements in terms of bandwidth, latency, and computation. And then, as has been said before by the other speakers here in the panel, also the interoperability of the data, so data modeling, and which I think European standards like ETSI are very on the forefront on this side in terms of the data modeling.
Thank you, Flavio. And it's quite interesting because that's very aligned with some of the things that Thomas Hans is doing within the International Manufacturing Council. I don't know if you're also members of that, but they're looking very much at some of these themes. So it does seem that there is a a trend towards really establishing the a framework, an operating framework in which data can be shared safely, securely, and obviously, you know, while retaining your own ownership of that, which is absolutely critical for any industry, particularly for manufacturing. So, Maze, could I come back to you? What are some of the areas in which international standards are going to facilitate the take-up of 6G technologies very specifically? You already mentioned data and AI. Could you perhaps provide a little bit more information on that?
Yeah, sure. So in my view, I think AI performance indicators are going to need to be established potentially or standardized potentially for specific use cases, because we are going to observe quite a diverse potentially range of KPIs, and they, you know, some may suit one use case, but may not suit the other. So maybe goes hand in hand with standardizing use cases is the KPIs that goes with AI performance. We will also need to look at what would be the rules of exchanging AI models. So in the framework of federation, as we see, federated learning has been picking up quite rapidly in Europe, and quite, you know, possibly faster than the rest of the world due to the nature of our substrates. And so we will need certain standardizations of how AI models can be exchanged and how can they be onboarded, verified within federation frameworks. I think also that goes hand in hand with sustainability of AI, and not only from an energy perspective, because AI is a computation intensive and data intensive service, but also so it's not just from energy perspective, but also AI sustainability from data. So if AI is provided certain levels of data, can we establish what are the data models, what are the data quantities that need to be provided to ensure certain performance levels within certain energy consumption or energy profiles, not necessarily just consumption, but cost as well. Yeah, and all of that goes within the federation of, you know, different AI models from different providers, different actors in the 6G ecosystem. I think a lot of our work in the coming years is going to be centered in terms of standardization around these areas. Yeah.
No, I think so. And in fact, George alluded to some of those also in his presentation. He was, you know, actually pinpointing some of the standardization measures already underway with ETSI. And I think Francesco also alluded to the need to ensure that sustainability with his comments on, you know, you have the functionality, but from a business perspective, you also need to make sure that the cost is at the right point, and that's essentially just the business case. Nobody's going to be investing in infrastructure or in any type of development if that return on investment isn't clear at the outset. So Ruth, can I ask you, are there any specific initiatives that you're aware of that Europe is undertaking to help ensure that development of global standards is happening, and that we have a seat at the table, and it's based on technologies, on technological requirements and functionalities that we are pursuing here?
Well, I'm aware that the 3GPP and the ITU have initiated discussions about the global standardization efforts for 6G, and they are underway. And I think they've signed a recent document just towards the end of 2023 that established the guidelines for standardizing 6G requirements. So I haven't looked with full details on the document, but yeah, it will be setting up some of these areas. And within the research community, so within the 6GIA, we started looking at sustainability and AI robustness, you know, and the fact how can AI-based services be provided over the heterogeneous infrastructures that we have in Europe. So this is underway, and this is meant to inform on the strategic research and innovation challenges that Europe is going to face in 6G for the next, you know, upcoming years within the time frame of Horizon Europe. So these are a couple of the examples that I'm aware of. Trying to think if there is something else. Possibly there is more.
Yeah, thank you. I was going to say, Ruth, I'm sure that you will, for a start, there's Insta, but please do share your activities
Okay,
here.
so the key, I would say the key initiatives currently in Europe are, of course, 6G IA and also 5G PPP, the former one, Networld in particular, where several of us are involved and steering, let's say, or have been steering over the last possibly 20 years, the vision for 5G and then 6G, so beyond 5G, 6G deployment. So in terms of, I would also raise the attention, okay, to some initiatives where anyway Europe is involved, but for instance, the USA Next G Alliance, because it is important to take a look also, so that there are of course initiatives being developed around the Next G Alliance focuses on 6G, considering the societal sustainability, so technologies, the spectrum perspective, so very, very similar to what we are doing in Europe across different initiatives. I would say a key aspect that possibly is different is really a strong push for Open RAN. We also have it here, of course, but a strong push for Open RAN, considering that there are higher frequencies also involved, because in the USA, the spectrum splitting is different, as you all know. There are other initiatives that are interesting across the world. Okay, so there's the Indian one led by PM Modi. Okay, so the Bharat 6G vision. Of course, India, for instance, just to give an example, and I'll explain why. India just launched 5G, so last summer, which is completely different than what we have in Europe, where we have 5G already in several countries, and also in the USA, where at least in terms of roadmap, it is claimed that it is closed, but in fact, in terms of subscriptions, there are 40% of subscribers for 6G. So in comparison to what, so to the I think 270 million subscribers for 5G. So these worlds are very, very different, and indeed there is alignment. So here in Europe, we are starting a new cooperation and support action, as Tanya knows, because Tanya leads it. Instar just started this year, and actually one of the things that we want to do is actually to help in understanding better these alignments. So there are already other initiatives. The Next Generation Mobile Networks Initiative also has released a view, I believe, last October. So a document about an overview perspective on 6G requirements, already integrating the visions of China, Europe, and USA. So these are aspects that are important to understand, okay, this alignment, what is similar. So for instance, in terms of use cases, there are major differences between Europe and, for instance, India. We focus more on, let's say, the infrastructure part, mobility, USA also, so where infrastructure means farming, means manufacturing, of course, while in India, for instance, the focus, or in China, I believe, the focus is more on autonomous vehicles and remote controlled factories. So this kind of aspects would be important to align and understand the challenges that we have and why standardization is using specific methodologies.
Thank you. And again, I think that's one of the key areas of work for the Enable 6G partners. And I think Timothy was also sharing some data on that. It's absolutely critical that any technology is developed with the context in which it is going to be deployed fully in mind. Otherwise, it won't necessarily have functionalities. And again, the role of standards there. So you might have horizontal standards that refer to the technology, but then you probably also have some vertical standards that are either industry specific, and those are going to be determining whether something can be used within a given environment. Automotive, for example, is very restrictive in what can be done for obvious reasons. But I think that this is also cue to Flavio to come in, because I think Ruth just really emphasize there the need to make sure that there is interoperability, that standards do talk to each other, you know, with the example of India and how they are very divergent from the path that we're taking here.
Yes, so to say like how the European projects work that's a wonderful job, because I mean like European projects really are interacting very closely with European standardization bodies, But European projects also allows to have interaction with other countries. So there is often European projects with Japan companies, European projects with Korean companies, or with Indian companies. So with this approach, there is a good thing of experimenting really with research and innovation approach and development of pilot projects to test on real scenario, on real pilots, the standards that has been, let's say, specified in real testbed and in, let's say, in real use cases. These will, on one side, understand like how actually the interaction and interoperability between continents in this case, but also between companies in different also perspective might work. But on the other side, also provide like the possibility for let's say open new market and having new adoption, a mutual adoption between different market in terms of different countries. So another very good example. So some good examples is the fact that the standardization in EU is working a lot with implementation-driven foundations, like, for example, FIWARE or NDSA. So I can say, for example, for FIWARE, NEC has worked just as personal experience, but there are also other cases. Has worked a lot for smart cities in Japan or in India and in Europe to bring similar solutions with the same standards for smart city solutions, similar what also Telefonica has done in South America, in Latin America, and also in Europe as well. On the other side, for example, like what I mentioned at DSA, there were also, let's say, examples of pilots, cross-boundaries pilots between Europe and Japan for logistics in terms of industrial scenarios for logistics in a port, for example, between Japan and Europe, and implementation of data exchange and automation of process with different companies and different also way of working.
Perfect, thank you. And on the ports, in the next panel, I know that Nacho Lagalle is going to be talking to Maria Shao about, possibly he'll bring in the theme of ports, but it's something that I know that he has a lot of experience on, and standards are absolutely critical again. And they're, by nature, they have to be multi-partner and absolutely international, otherwise the whole of the logistics ecosystem falls down. Carlos, I think that you've been waiting very patiently there, but it's we've been talking about standards that are in development, but what happens once a standard is developed and is adopted? First of all, there have to be drivers of adoption. You have to make sure that people adopt it, and then you need measures or mechanisms to make sure that somebody is compliant, so certification, which is your field. Would you be able to share some of your views there in relation to what you've seen in perhaps other areas that might be similar to 6G in terms of the process?
Yeah, let me just share one slide.
Yeah, go ahead.
Just 1 second. I can find it. Sorry for this. I thought I had that. Yeah.
Well, while you share, perhaps a couple of calls to action while Carlos finds the slide. We are, as Ruth said, we're launching INSTAR, which is a European Commission coordination and support action to work on standards in 6 key areas. One of them is 6G, 5G. And we're going to be working on roadmaps with Japan, USA, Canada, Taiwan, Singapore, Australia, 7 countries, so 7 like-minded countries, so do reach out. And the second call to action is in relation to 6G SNH. There are going to be some calls. I don't know if they're open now. Maybe Mace, you can share some information on those, or we can in our follow-up email. So there's a lot of areas for collaboration between everyone on the call and the different speakers and generally the 6G ecosystem. So please do keep in contact with us. Carlos, do go ahead.
Can you see my screen? For whatever reason,
yeah.
I
We,
cannot.
yeah, you're on, but we only have a couple of minutes left. So if you could.
Yeah. Okay. Well, let
thank
me
you.
let me just quickly.
Yeah.
So the reality is that a technology, when it goes into standardization, is typically driven by a reduced number of companies. And they start working on the implementation of this technology and typically deliver a pre-standard or an early standard implementation of a certain technology and try it in the market on a very limited scale. But moving that to a bigger scale requires that many different vendors can implement that technology specifically. And this is where the Global Certification Forum has been working in the industry since 2G. We've been there in 2G, 3G, 4G, 5G, on making sure that we can deliver a ecosystem level playing field so you can test your implementation before going to the industry and can work with different implementations from different RAN vendors, from different core vendors, so that when you put your device on the field, it works. And this is something that is industry driven, that is collaboration driven. So typically, companies that are interested to make it happen, bring it to the GCF based on the test specifications that are already done by standards bodies to make this happen. So this is key for making a technology that is standardized grow, because if not, it is very difficult to make sure that you are able to deploy it through different countries, through different vendors, and through different manufacturers. And that is something that the industry learned many years ago, and the GCF is supporting. We are a non-profit organization. We are a member-driven organization with more than almost 400 members from all through the industry. And this process is key to make sure that if you work for something and something is led in a certain geography, is tested maybe for a certain band, but the basics for making it work is done, and the test industry is able to offer solutions for this and offer it through different standards and through different frequency bands in the future. So that's a little bit I would say the situation, or what GCF offers when the standard has already been produced, and in the interim when that standard is being deployed till it gets massive in the market.
Thank you. That's really interesting. So it's a test before you buy approach as well. So you're making sure that regardless of whatever happens to be agreed on paper, before it gets to that stage, there's a real world implementation of that, and it's coming. There's at least some connection that the standard would be scalable and relevant across different geographies. Very interesting. Thank you, Carlos. So we're out of time. I've begged 5 minutes from Maria Shao. So Maria, forgive me, 3 more minutes. I just wanted to ask you all to perhaps just end with one phrase on what you would think would be a key ingredient for successful international collaboration on 6G standards as a precondition for market take-up. And I stress that, the precondition for market take-up, because as Carlos has just highlighted, ultimately that is what standards are there for. They're really there to ensure that adoption can happen as broadly and as widely as possible. So perhaps Flavio, to start with you, what's your one key ingredient for standards for 6G?
Yes, in my opinion, is to find the killing use case. I mean, like as 5G really worked on, let's say, connecting everything with Internet of Things. Now we have everything with automotive, smart home, and digital health. I think the next thing that we should target is a new killing use case. In my opinion, would be the digital twin and metaverse. That is, we're setting the standards and we're setting the implementation approach, and then we also set already from now what the market will need to adopt and push for.
Thank you, Mace.
Thank you. Yeah, in my opinion, it's federation. That's the key ingredient that it will enable global interaction, and federation that allows for coexistence with minimum disclosure of knowledge and information, because without that, it's very hard for industries and different actors to actually collaborate with each other.
Thank you. Ruth, please.
So my view is open experimentation. So in order to allow the standards to evolve fast across continents, we need initiatives that provide us with open experimentation, allowing a strong cooperation between large industry and academia or research, as we do in Europe, but cross continents. Thank you.
Thank you. And last but not least, Carlos.
Well, I think it's making the level playing field for spectrum. I think it's key. So if the spectrum is prioritized, saying we are to work on these specific areas first, it's much likelier that that can speed up things on the deployment, because there are many different places in the spectrum where the 6G technologies are being positioned. So we cannot cover all of them at the same time.
Thank you. And I think it was again that was either Timothy or Nicholas who also referred to that. And perhaps just to come back to Flavio's comment there on the use case, Telefonica, of course, had the use case of the home as a computer, which is really quite interesting. I hadn't heard that before, but I look forward to seeing that develop into reality. So, well, I think we're completely out of time, Maria. Thank you very much for bearing with me. I would like to thank Carlos Pedraz, Flavio Cirillo, Mays Al-Nadai, and Sofia for their wonderful insights, and very much look forward to continuing to work with you all in the future. Thank you very much. Maria, you can take over now. Thank you.
Yes, hi, thanks, Tanya. Fascinating, and also a lot of the things that have been said in this panel are actually a nice lead into our panel as well. So the panel that we're going to have now.
Sorry, Maria, to cut across, your microphone is a bit tinny. Would you be able to change your microphone?
Yeah, just 1 second.
And while you're doing that, I'll introduce the panel briefly. So final panel of the day, Maria Xiao, who is moderating, comes from a background of electronics engineering and also then a distinguished career working in many different telcos through AT&T, IBM, Cisco, Orange, Flag Telecom, before moving on to work on investing in smaller companies, supporting business development and mentoring roles, and is also a member of the EIC jury. So fittingly, she'll be moderating the panel today, which is looking at really this application informance moving forward. Which is with Romano Ros from Multiverse Computing based here in Spain, Ignacio Lacalle, who's a researcher from the Technical University of Valencia, who is leading on key applications and use cases across the edge computing divide and domain in this area, Claudio Fiandrino from Indea Networks, who's a senior researcher, and George Makaropoulos from the Democritus, the research center based out of Greece as well. So Maria, maybe if I hand back over to you now.
Yes, can you hear me okay now?
Perfect. Thank you, Maria.
Sorry, some of these USB things. So I do have to share something with you guys, is that Roman has had a personal emergency. So he unfortunately won't be able to make it to our panel today. But anyhow, I am sure other people can maybe comment on quantum computing within the other speakers. So yeah, so I think we're the panel that's standing between you and lunch, probably. But a very exciting panel, because we're getting to the very exciting area of AI and embedding AI in 6G network technologies for the future. And so so I'm going to be so we have the panel was introduced, and so what I'm going to start with is a brief introduction from each of you, introducing your research area and what you believe could be that killer app that was mentioned before. And in your area, what do you think is that killer app that may improve adoption of 6G technologies? So let's start with Claudio, please.
Sure. Can you hear me well? All right. Great. I'm a senior researcher at Indea Networks, where actually I lead a subgroup on resilient AI network. What do we do here? Essentially, our main goal is to enable trustworthiness in AI for 5G and eventually later 6G networks. And concretely, we do this basically by developing new techniques, new methodologies that focus on those specific mechanisms that basically improve network operation. Concretely, we focus a lot on those models that perform forecasting. So this may be traffic forecasting, forecasting traffic volume, forecasting channel, how it look like in the future, because all these techniques basically can be reused by network mechanisms. And on the other hand, we look into those models that actually enforce, basically those models that look into the decision making, that is reinforcement learning. And we basically strive to understand how this model works, because most of them are black boxes. And we because of this, we are able also to improve how those network mechanisms that use these models. And if I have to say the groundbreaking use case, well, I strongly believe that if we are able to create an ecosystem for AI, well, the trustworthiness is really pillar. And like Mace was saying before in the panel, this also comes into play with the basically standardization, making sure how AI looks into treats the data. With 6G, as we heard all today, it will be a massive amount of data stemming from sensing application all the way to the actual network operation. So making trustworthy this ecosystem is really crucial if we really want to build such a native AI 6G networks. So that's my take on this. Thanks.
Yeah, thank you very much, Claudio. So let's move on to Nacho, please.
Yes, great. Thanks, Maria. Thanks all. Well, my name is Ignacio Lacalle. I work for UPB, Universidad Politécnica de Valencia, which is a polytechnic university at the southeast of Spain. I belong to the communications department and to a research group that is mainly focused on investigating the edge to cloud computing continuum. We have been, since the last 6 to 7 years, coordinating and participating into back-to-back Horizon Europe and Edge 2020 projects, trying to understand and relax the complexities of integrating and making interoperable different computing equipment and different necessities from IoT to edge to cloud, so that everything can be assumed as one entity. And we believe, with our work in the past and the new advent of the new AI techniques and the miniaturization of computation, all fits very well together in the advent of 6G. As you know, one of the main goals of 6G, apart from making more, lower latencies and more frequency and speed, is to have more edge computing also across the deployment. Therefore, the technologies we develop, I think it's basically fit perfectly into this new generation of mobile communications. And within that, we specifically focus on AI applied to network improvement, right? So that's basically our role, and I hope to be contributing to this panel thereof. Thanks, Maria, and thanks all for the invitation.
Yeah. Let's move on to George, please.
Hello, can you hear me?
Yes.
So hello everyone, I'm George Makropoulos. I'm a research engineer at the National Center for Scientific Research, Demokritos in Athens, Greece. So actually, first of all, to say that it's a pleasure participating in this panel, this insightful panel, and this event in general. So as a member of the Front Research Group in Demokritos, which actually stands for the Future Communication Networks, the acronym, some of the pillars that we focus on revolves around automated experimentation on top of 6G platforms. We own a testbed that is being now updated in order to support experimentations related to 6G. So we are utilizing all these technologies that have been mentioned previously, and we're trying to improve our testbed. And also we are focusing, I'm specifically focusing on the network openness and the native AI, the integration of native AI which is, of course, a concept that can be applied in several vertical industries. So now, focusing a little bit on the part that I'm actually working on, which is, as I mentioned, the programmability of the network and the capabilities that this new openness that was initially introduced in 5G and now continues and will be leveraged in 6G offers. I could say as let's say, a more tangible example, or I wouldn't use the term groundbreaking, okay, I'm keeping it on the safe side, I would say interesting, is the combination of the 6G network's openness and the native AI capabilities, for example, in a UAV operation. So consider that we have a UAV that wants to move to a point A to point B. Through the openness of the network, we are able to retrieve data and inputs coming from the core, the RAN, or even the APIs of the network. All this data can be fed in an AI module, and by modeling this data, we can predict the safe pathway from the takeoff to the landing point, considering the QoS status of different cells across this flight path. So, as you can see, I try to say a tangible result to understand that we have several capabilities now in our hands. We need to move a step forward, and by integrating AI in the 6G networks, I think that we can leverage the capabilities that we already have in our hands.
Okay, so thank you guys. Very interesting, and I think everything is quite complementary to each other. So let's start on this this first theme of AI and embedding AI, which I think all of you are doing in your area. So I think it's a question more for Claudio. Of course, explainability and trust is the biggest thing right now in AI, including in standards, as we heard before. So how are you kind of pulling together kind of all the developments that are happening, not just in the networking and the 5G to 6G area, with everything else that is going on with AI, just in general, right? Across industries, across tech in general.
Thanks, Maria. That's a very interesting question, actually. That's true, because these areas are growing at such a fast pace that it's very hard indeed to pull everything together. So essentially, on the one hand side, we really look into the latest advances, standard, and for example, we have to say that ORAN has really come as an help for the integration of AI, because if you think that right now, basically you can deploy into a real-time controller those very tiny software like XR or RAP that can actually be AI model. That's really the technology that for us it's crucial to use. So on that inside, basically we leverage this kind of advances, and on the other inside, from the AI community, there are so many advances in a number of fields that that is very hard to keep up. But we really try to focus on very key points. And for example, for time series forecasting, we use the latest models that have been developed in the recent months, not years, in the recent months, so that we are really up to the state of the art. And indeed, we are actually putting together right now a very small workshop paper where we are trying very advanced techniques for AI forecasting that are extremely simple, very, very simple in terms of model complexity, but at the same time, extremely accurate. And for example, this compare with respect to state-of-the-art model like LSTM that everyone used, it's really not one order of magnitude, but it's really a huge improvement, like more than 10-20% of model accuracy. So given this, this is basically just to put together technologies, and the biggest challenge is basically to develop the techniques for explainability that go and robustness that go on top of these of this architecture from the one side and model from the other. And essentially there, basically we do what I call we're developing the second generation of explainability techniques, in the sense that explainability is already there for AI models, has been there for a number of years right now, but that was conceived essentially for imaging techniques, imaging application, imaging processing. For example, in terms of healthcare, right? AI is widely adopted for doctors as an help to understand, for example, the dimension of cancer or other things, right? But in the network context, this is slightly different, because AI will not be just an help, will actually be the key point that takes decision. For example, takes decision in terms of how many resources will actually provide provision to, for example, a given network slice. And because of this, we cannot rely on those techniques that are based on image. We have to develop techniques that go beyond and do not just reveal, for example, the relevance of the inputs, but actually give a profound insight in terms of network behavior. Just to give you an example, that the team was presenting later today, one of our work that looks into reinforcement learning. And there, our explainability basically tell if an agent is augmenting the network throughput or diminishing the network throughput given the impact it has on the buffer that the users have on the. So that's the way we are keeping up with this challenge. From the one side, to ramp up technology advances from the perspective, keeping up with the state of the art on AI, and basically to put out together developing techniques that are advanced and are basically what is really needed to create such a transparent AI for 6G networks.
Okay. Super. Thank you, Claudio. This is a great lead into Nacho's area, because obviously we're talking about big and small models, vertical models, all kinds of models, a lot of possibly real-time type considerations. And so there's actually your area, right? Nacho, kind of the I love that word, sort of cloud edge continuum. Holy grail of telecoms. So how does that then kind of come into what you're doing, which is basically making sure that all of this will work, I guess, in a few years down the line, will work in actual networks, and the infrastructure, the cloud, the edge, AI everywhere. How does that reflect in what you're working on?
Yeah, well, this is a very, very nice reflection. And about the actual word of computing continuum, I would like to point out that we are all kind of trending towards this term. This very webinar started this morning with a graph which indicated which is the actual goal of 6G in terms of deployment, having everything as a continuum for deployment. So it's not only just us pushing towards this term, nor even the Commission. I believe all of us are trending towards this one. And what you point out, it's actually very interesting. What we are trying to do in the different projects is to homogenize, or better than homogenize, harmonize the underlying kind of infrastructure coming from both IoT, edge, cloud worlds, making it interoperable in terms of how it is defined, how it is accessed, how you define the characteristics of computation, the characteristics of network interfaces, the protocols that are accepted, that are allowed to be used. Try to generate a framework, both in specification and in technology deployment, so that it's able to be used for performing these type of services. And all of these arrangements are made smart by the AI. Basically, if in future 6G deployments, network deployments, we tend to think that both, all ranging from these large data centers with the backhaul of the network will take place, up to more edge devices in MEC, and even if in the GNB nodes, and even beyond, up to user equipment. All of those should be able to form a mesh of solve collaborative elements. So where concurrent achievement of objectives, concurrent sharing of the data that is captured by the network can be shared, and AI can be applied scattered across these elements, thanks to exposing them as useful elements in such a continuum, so that what can be shared in a part of a network can be automatically translated to another part of the network and make it overall much more efficient. This poses, of course, relevant challenges, such as, well, if the different equipment come from different equipment providers, if they do not adjust to the same requirements, how do you relax the dependency of those off-the-shelf solutions, how you make those interoperability connections available, and we are working on that. It's of course not solved, but there are trends, and we believe that we will get this by the time when 6G deployments will be able to be a reality. And I would like also to add here that thing that Tanya pointed out as moderator of the previous panel is true, is that we are building, when it comes to more edge equipment and even farther the user, we can deliver certain things academically, and we of course push for doing that. So we are universities and in projects, but when you come to the actual reality, there are no clear following of standards. When you come to that world, and the definitions are not very clear, and you need to be playing in a very different playground. From what we have learning on experiences in challenging environments, such as, for instance, maritime ports, is that apart from defining this global framework, applying these AI models here or there in simulating scenarios, a lot of adaptation is required when real-time deployments take place. So making the primitive research or the low TRL research already adapted to these potential adaptive circumstances later is also a challenge and beneficiary. So basically, that's our thoughts on how to make those stretching heterogeneous equipment underlying able to first embed the AI and then be useful in the 6G deployments. That's what I would say.
Okay. Thank you, Nacho. Hold on to your thought about real life, because I have another sort of global question for all of you as well on that. So, George, some of the concepts that you mentioned kind of made me. So, for example, the UAV example, which is kind of pretty real life example, made me think of some like existing developments, right? Like, self-organizing networks, all of that technology. So how do you think that, where do you think that the AI sort of capability and innovation is gonna come from? Because here we're talking about two very big verticals, right? So there's the enabling telecoms networks, but then obviously a lot of the people are from the sort of the more transportation type industry, and then you have the real heavy duty, pure sort of IT. It's kind of a similar question to Claudio's, right? And there's kind of the heavy duty IT, pure IT, AI players. How does that come together in your area?
Sorry, can you hear me now?
Yes.
Okay. So actually, this is a really good question, because of course we need to see how we can combine all these technologies in order to support the different areas. In my view here, most of the work is related actually to the regulations and the standardization aspect. So I think that before the technologies, I think that we need to make a clear clarification on the regulatory aspects and the standardization aspects, because if we don't have this aspect, we cannot move with the technology. So, for example, transportation, okay, this is a really good example. Industry 4 as well is a really good example, and now we are progressively moving to the digitalization of the industry. So all in all, I think that we need to focus on the regulations, the standards. We need to set clear and robust privacy measurements, security protocols in order to support this smoother adoption among all these sectors. And in parallel, we need to focus on the scalability and the interoperability considerations, because the design of AI and the integration of AI in the networks comes with scalability and interoperability that will ensure that these technologies can evolve and can be easily adopted by the different industries. So that's my view.
Yeah, so perfect. You guys are very well prepared. So talking about other industries, customers who are piloting with you or working with you. I mean, obviously we have a few here. So we've got sort of the telcos. So I'm gonna ask you the question. So when you talk about like your customers, right, or your pilot customers or people who you're working with outside of research, right, people who are more the end users at the end of the day. How mature do you believe they are in terms of the maturity? You mentioned this, Nacho, right? We're doing a lot of research, but then obviously you got to go to market afterwards, right? So how far are we? Is there in your respective areas a good understanding of the speed at which all the TRL levels need to kind of be achieved, or do they have a people gap, right? Is there a skills gap in AI? Can you have those conversations with them, or is it more like R&D is going to do this, then hand over to other teams, and then hopefully somebody in the industry will pick it up? Nacho, you seem to be very eager to answer.
Yes, let me try to pose this nicely and simply. I believe there is a very, very huge gap, because there are certain type of entities that even do not want to talk about this kind of deployments until the standards are applied, the commercial mainstream is there, the spectrum is licensed in the respective countries and areas, and then they start to talk about that. So there is a huge gap, because we need to be working years in advance that this happens, of course, for it to be ready when the moment it happens. So you can sometimes only engage them in this kind of a very small scale project, very small scale initiative with very controlled environment, with your own private under control spectrum and so on. So this gap, and I don't know if this would be solved, because this is how, you know, the mobile communication world evolves and has always worked. So I don't think it's people gap, but more temporal gap, and their lack of understanding of what will be able to be done until it's there. So this must always bear in mind in these conversations.
Yeah. Claudio, any comment on that?
Yeah, from my side, I think that there's a gap also in terms of the skills, basically, that our developers and engineers have to come up with, because essentially, if we look ahead in the near 2 to 5 years, there will be a massive AI improvement in terms of model, and what will happen most likely is that there won't just be one AI model taking care of a specific mechanism, but there will be basically an ecosystem of interacting AI models. At that point in time, if the developers are not skilled enough, the risk is really that we don't know anymore who's accountable for what, right? So I really foresee that in terms of gap, what we really have to fill in is a clear understanding of what either on the one side what the AI models are actually capable of doing, and then on the other side of what the networking, let's say, ecosystem in terms of developer, practitioners, engineers, MNOs, and etc. Know about AI in the first place. So this is really the main takeaway from this, that we need really to make sure that all the people working in this ecosystem actually become skill and knowledge actually make sense of it.
Okay, George.
Mm.
Yes, I fully agree with Claudio in the sense that I also recognize a kind of gap in the fact that the developers and all the people that are involved in this process is something new for them. So we need to engage them somehow with initiatives that will give them the knowledge to understand better the integration of AI and how to improve the network's operation. So all in all, that I think that the focus should be on the people that will be involved in this process, and afterwards, the testing and all the activities can take place in a smaller scale environment. So to have a better understanding in order to move to the larger scale. So Claudio had a really good point on this, that people are important factor in this path.
Okay, so so this is yeah, great feedback. If so we talked a little bit about this, right? These are kind of the risks. So we're talking about sort of Nacho's talking more about like the risk of basically having the same timelines and the same view of where we're gonna get, and the chicken and egg kind of problem also with obviously standards. So what do you think this industry, what would be the one thing that you guys think that could really accelerating adoption in terms of time, accelerate the adoption in terms of having those conversations with end customers? If there's one wish that you had to kind of move things forward in a successful way, what would it be?
For me, quick standardization and large-scale deployments where the outrageous speeds that can be achieved are demonstrated. These two things.
Claudio?
To me, it's really about making provable what the AI models are doing, in the sense that we make sure like they are interpretable, explainable, that are understandable by all layers, stakeholders, network operators, practitioners, engineers, etc. This will really accelerate and boost confidence about the integration, the real integration in production network.
And George?
I fully agree with both guys previously. I mean that, of course, standardization is again a major aspect, and I would say that collaborative partnerships within the different domains could help in creating a more mature environment for a wider acceptance and earlier acceptance of these innovations.
Great. Well, that's it for our panel. So I just take a couple takeaways because this is music to my ears, being an ecosystems person all my life. So we're talking about the ecosystem, people, talking, collaboration, standards, all of these things that Tanya knows how to do very well as well. So I'm going to close the panel. Really, really huge thanks to George, Nacho, and Claudio. And back to you, Tanya.
Thank you all.
Thank you so much.
Thank you all. Thank you.
Thank you very much, George. So yes, we've got 3 minutes. 3 minutes to thank everyone, George and the team at INDEA for bringing us into this this party in the first place. But if I start from the top, thanks to Brendan, Jose Luis Lorenzana, Timothy Otim, Nicholas Cortelis, George Widmer, Francesco Devoti, Thomas Hahn, Carlos Pedraz Rodriguez, Ruta, Sofia, Flavio Cirillo, Mace Alnadai, Claudio Fiandrino, Ignacio Lacalle, George Macropoulos, and the marvelous Maria Shao, with whom we've had many opportunities to engage with over the last, more than a decade, I think now, Maria. So it's a real pleasure to have these excuses to bring everyone to the table and to share their views. We started off with a very technical review of what reconfigurable intelligence services can do for new networks and infrastructure to deliver 6G. We've seen what the advantages of 6G can deliver to end users in terms of applications. We've discussed some of the enabling factors also from global standards, but also how infrastructure, what are the challenges around investing in that infrastructure, and the need to make sure that any investment actually has a business return across different multiples of verticals. And finally, we finish with trustworthy AI, which is absolutely at the core of not just technology within infrastructure and networks, but across very many different enabling technologies and enabling environments. So thank you very much, everyone. Thank you very much also to colleague Isis, who you can't see, but she's been behind the scene. I know that many of you have been engaging with her. Please stay tuned. We will be sharing short summaries of what we were discussing today, and insofar as the speakers also enable us, we'll make sure that there are also links to the different presentations. Again, thank you so much, and I look forward to seeing you at our next event. Have a great day, everyone. Thank you.